Afternoon, everyone. As I was introduced, Malcolm Schulstad, Chief Operating Officer of MOVUS. I'm here today to share some insights that I've gained over the last 7 years on the main reasons predictive maintenance seems to sometimes fall short when it comes to modernizing maintenance practices. Just a disclaimer, though. I did actually put this presentation together while I've been on holiday in Japan for the last 3 weeks. I won't translate that, but the gist of it is that I did happen to write this presentation in a hotel which had free sake and beer after 5 p.m. And in case you want to know what that hotel is, it's Hotel Wood in Takayama in Japan. So 7 types of sake. Okay, once upon a time, I joined MOVUS late in 2019 with pretty much no idea what AI was or how it gets developed. I was in disability support work before I joined MOVUS, and as you can probably imagine, there's not a whole lot of calling for AI in that line of industry. But surprisingly, MOVUS hired me anyway, and I was introduced to the world of data science. They had a group of people with PhDs. This was one of them. His name was Paul. He actually looked like that. They threw a lot of big words at me, which I didn't quite understand, and asked for some expensive computer gear, which I couldn't quite understand how I was going to justify, because to this day, I'm still not quite sure what 3D VR gear did to help develop data science. But in any case, we got that equipment, and before I knew it, I was trying to understand what the data science team was doing. They threw terms at me like neural networks, gaming theory, dimensional reduction techniques, and a whole lot of other stuff that generally went over my head. But that last one, though, this is where they use the 3D goggles. They did help me understand over time what it was that they were actually trying to do, which was to develop a next generation of AI that could predict the current or future condition of an asset using an existing machine set of data that we had. So there was some promising work that was done. We were able to categorize some of these data sets into groups, but the challenge was, at the time, our data points weren't tagged or labeled very well. So in those groups, we had no idea what they actually meant. So we ended up trying to solve a simple solution, or simple problem, which was to try and identify in an unsupervised state what the running condition of an asset was based on existing data. It looked like it was going to go well. Results were promising initially, but over time, as we kept going with this analysis, we found that the AI model repeatedly failed and broke down. Why was that? So we found, when I spoke to the data science team, I discovered that they didn't think the quality of the data was actually very important. They thought quantity over quality would actually solve the problem, otherwise known as the big data thing. I'm personally a bit old school when it comes to that type of thing, garbage in, garbage out. And in the case of the Galaxy Initiative, we discovered that a lot of the states that we identified as running or not running were actually incorrect. And beyond that, there were a number of edge cases, scenarios, and situations where the running data would change over time, and we couldn't guarantee that even if it was set correctly, that it would be correct in the future. So I think the big data theory does work if you have a lot of data. So you can use quantity to overcome quality. We couldn't do it here because we just didn't have enough of that data. And when I talk about a lot of data, I'm thinking in terms of what large language models like ChatGPT use. So in the absence of a truckload of data to make the model work, we ended up having to go back to parking the Galaxy AI and using traditional VA techniques to diagnose issues. But more importantly, on the back of that, we actually built validation mechanisms to ensure that we could capture and maximize feedback to improve and make our AI more accurate over time. That was the theory in any case. One of the challenges we had, though, is that systems, no matter, they're great if they're used in the way you intend. But Murphy's Law says pretty much that this is never going to happen, particularly when you have people involved. So You'll find now that most predictive maintenance systems in industry not only alert or diagnose issues for you, but they do give you the facility to validate the data that people are using. In Australia, though, and in a lot of other markets, what we find is that resources in maintenance and reliability are always pretty tight. And that's the way it's always been. They focus on getting the physical work done, and that's their priority. So despite predictive maintenance systems having the capability to take in data and become more accurate, it just doesn't happen consistently at this point in time. And that's largely because the benefits of validating or invalidating data aren't quite understood. It tends to be a future benefit that people may or may not recognize over time. What is easily recognizable is the need to get something back up and running, or do that critical PM that no one ever has time to do. And that's what they tend to focus on, rather than ensuring that effective feedback is provided within the system. So even after a decade, sometimes longer, of condition monitoring and predictive maintenance, we find that many companies are still failing to maximize the benefits that they can get from deploying predictive maintenance. And a lot of this is just to do with getting the right feedback. So from a systematic perspective, we can summarize this into two feedback loops. In the loop with no feedback, we have the situation where the end users provide limited validation of alarms and diagnosis. This can and does tend to lead to a perceived or a very real increase in alarm noise. And at that point, nothing limits the widespread deployment of predictive maintenance more so than alarm noise, because it's at this point that operators start ignoring the system. We end up with a distrust in the alarms, the and the system at large. And this is when operators and users start abandoning the use of the system. The system falls into neglect, which leads to a further increase in alarm noise, and so on and so forth. Best case, you'll end up with a small team on site or a single operator that still understands the benefits of the system and tries to keep going with it, pushing the benefits. Worst case, the use of the new predictive maintenance system falls away, the costs of the system gets questioned, the system gets pulled out, and we're back to the status quo. If the data, in contrast, if you have a team that is providing feedback and validating the data, this data gets used by a predictive maintenance system provider to optimize the existing AI or develop a new machine learning algorithm that will help to improve the accuracy of the system. If the data is correct, the end user thinks, great, the trust increases and the system continues to get used. If the data is incorrect, end user puts this feedback in, changes are made to the system, it's improved, the end user becomes part of the solution, which also helps to increase the mechanism of trust. As trust in the system builds, this shift to using near real-time condition monitoring data occurs, and the point at which maintenance practices can be modernized and making use of the predictive maintenance system data and its validated data happens. So the importance of the feedback loop becomes understood, and the cycle continues to improve the accuracy of the system, eventually leading to prescriptive maintenance, which is where we're providing actual accurate actions in a timely fashion on what to do, not just a diagnosis. So a case in point, because all this sounds good in theory, but what do we know? What actually happens in practice? In our Plant OS platform, capturing customer feedback and data has been a focus for many years now. And so we ensure that happens every time it's deployed. The stats you see here are from a random selection of data in the platform, a snapshot I took in Japan of monitoring results over the last 12 months of just under 14,000 assets. If you're wondering if this is genuinely random, I'm going to go back to my sake comment of it being free earlier when I put this presentation together. Over the last 12 months, there were 11,000 faults identified. Out of those, 768 were marked as incorrect, meaning just under 93% of those diagnoses were actually correct. When I looked at this data set 3 or 4 months earlier, that number was 92.5%. So even in that short period of time, the accuracy of the system has been increasing because we continue to get feedback that helps to optimize the system. Out of the ones that were incorrect, less than 5% were actually related to no fault found or alarm noise. But perhaps most importantly, the number of issues that were actually missed was a total of 51 over the last 12 months. So that's less than half of the percent of issues reported that were actually unplanned downtime, or as someone once described to me, a rapid destruction process. I think the thing that I need to highlight about this data, though, is it all comes from our end user feedback, which is an excellent example of what happens when you actually focus on feedback, validation, and what you can do with predictive maintenance and moving forward into prescriptive maintenance. So the first path in modernizing maintenance practices isn't just about deploying a new or even upgrading your existing system. In parallel, it's critical to ensure a change management process is implemented to ensure an effective feedback loop becomes a priority as part of business as usual practice. Ultimately, it doesn't matter how innovative your solution is, what the capabilities of a system are, how many sensors you've deployed, or even how many data scientists you've got working in the background. To leverage the full potential of predictive and prescriptive maintenance systems, you need to get the end users trusting the system and engaging with it. Getting the end users to provide feedback not only works to validate the data, enabling the systems to become more accurate, but makes the end user part of building the solutions that they want and need to facilitate the trust process. And it's up to us to ensure that they're supported in doing this by driving the change to provide feedback as a permanent business practice and making it a priority within an organization. Once you've got the trust in the system, the users trust the system, and you know the data is accurate, then you can really step forward to modernizing your practices, reducing unnecessary PMs, optimizing your inventory supply chain, ensuring people are never around when you have a rapid disassembly process happening, and ultimately extending the life of your assets. So that's it. Thanks very much for listening.